Oh.
Why
Why is the off button? Okay, so welcome to the 70-30 podcast. There's a 70% chance we'll lock out. Rare occasion where we're on the 30% chance we're actually locking in. We're studying for chemistry.
Yeah, I don't know what the hell we're
I
doing.
don't know. Yeah. Okay. You need an actual lesson?
Yes, I don't know anything at all.
Okay. Huh? 70%.
Multiply it by -1.
What are you two doing?
Flipping it, and then this turns positive.
It's not very like that.
What? So
What are you two
Why
doing?
are you so loud, Oscar? You said you'd whisper.
It's because he has his thing. No, I'm sorry. I was speaking. I'll whisper right now.
Okay, so I have a pencil.
Are we gonna need a whiteboard?
Are we going to use whiteboard? I don't know. Okay, do you know what dynamic equilibrium means?
No.
Okay. Do you know what dynamic equilibrium means?
He's a bio kid.
Something with equality out.
Okay. Dynamic equilibrium basically
You actually have
is...
AP camera
No, he has AP Bio, right? Okay. It's basically where the molecules are going back and forth in their states either states or what they are, like whether or not they're products or reactants at an equal rate. So it's going from products to reactants at the same speed it's going from reactants to products.
Okay.
Here. Now you visualize it. We have
visualization and less talking in this episode. So mind that.
okay. So right here you have this is 1. It's 2, 3, 4.
Is this a 30%
Right?
chance we're locking in?
Yeah.
Wow.
And this is at time equals 0.
Okay.
And here we have at time equals 10, right? See how this one is broken apart?
Only one of them is broken apart?
Yeah. So this is the reaction beginning to happen. So this is where there's no reaction, where all the molecules are like the same, and these two being like separated is the reaction starting to happen.
Okay.
And at T20,
This is in
you have
reaction rate.
2 of them happening, right?
So every 10 seconds or whatever T is, 2 of them are breaking, or one of them are breaking
Kind of.
apart.
So this is like the next step of the reaction, and at T30,
But it's not always gonna be like in intervals of
No,
10. No.
no,
Okay.
it's like this is an example of equilibrium.
Mm-hmm.
1, 2, 3, 4. This right here, see how it doesn't change from here to here?
This one.
It's like staying the same.
This is in the
This, you would say that at 20, it's at equilibrium, because after 20, like, the phases doesn't change as much as this.
So like once you get a baseline of when it doesn't change, that's at equilibrium.
Exactly. And, like, graphically, it would be represented like this, where you start at 0 for the products, because see how, like, we'll call the individual ones the products, right?
Yeah.
See how you start with none of them?
You start with no products.
Exactly.
So that's
But
these are the reactants at the start.
Uh-huh. As
Time goes up.
as time goes on, you get more and more products. So that goes up until you reach equilibrium at 20. Then it evens out. And then it's the reverse for reactants. See how you have all of those reactants? So you start at like 4, and you come down until it reaches 20, and then you only have 3.
Okay.
That's equilibrium. Or sorry, it goes down until 3, and then that's equilibrium.
Yeah.
It's a dry erase marker. I
Okay.
just don't have like.
I got scared for a second. I was like, what the hell?
Alright,
Okay, so that's equilibrium.
There's no way I'm gonna be ready for reassessment by today. Because on the test,
That's not biggie.
I was 1 point away from the 88, and I thought I'm gonna do better.
What test are you doing?
But then,
Unit 6.
look at the question.
Unit 6.
Wait for algebra?
Stupid
But at
ass
the same
chemistry.
time, I gotta study Unit 7 because I have the test in 3 days.
Might be time to go home and study.
Yeah, I'm gonna go home and study, but I don't know if I should just worry about Unit 6 or just forget about it and focus on
I would
studying
focus on
now.
I would for algebra, right?
No, for Kemet.
Unit. I say forget about Unit 6.
And just make sure
And
I do
make
good
sure
on
because
this.
we were zooming through Unit 6, so I say just.
We're zooming through Unit 7.
I mean 7. Sorry.
Yeah. We
Where's
This is Unit 8 already.
Yeah.
Okay, well,
That's Chavez
Bro, I
though.
wish I was.
And what's it called? Yeah. So I say just focus on Unit 7, because Unit 6 we're completely done with it, and you have what 3 days to reassess.
Yeah, I'm not getting it because I also have to study for this.
Yeah, I'll study for this. Do you want to do that or do you want to keep?
I gotta lock in on this because I don't think I'm gonna do better than a 77.
On 7 or
At
6?
least, unless I go home tonight and I study and maybe I reassess tomorrow during flex. Okay. Are you gonna reassess now or during flex?
I would recess now.
Yeah,
You have time. You have like 30 minutes.
I'd go now.
You have 35 minutes actually. Alright, Philly.
Good luck.
Are you ready?
Ooh, name drops.
Alright, good luck.
Oh,
Studied it.
that's fine.
Like a good amount.
Oh, by the way, we're
On
here
what,
with.
AP classroom?
We were here with
No,
Castro.
this,
Castro's about to
like, all
leave.
the
And we
hybrids,
have
I
free
did them,
day,
like,
and we
3
have.
times
Do you
over.
just want to go
Yeah,
by
alright, good luck.
San Luis or what?
Saint Louis.
San
You got a new one in the studio.
Yeah. That's where he's from, right?
No, he's
Shut up.
What do you, yep.
his last name is where he
Shut
was
up!
from.
What? Where do you think he's from?
He's from Canada.
From what?
Canada.
Connecticut.
All right, well, whatever.
Same thing.
Connecticut is not Canada. Yeah,
Connecticut's not Canada.
Connecticut.
Okay, keep going. Keep
Okay.
on.
You know what equilibrium, like dynamic equilibrium is, right?
Say it again?
Dynamic equilibrium.
The what?
Okay.
That's-
So basically,
Huh?
That's fine. Okay, dynamic equilibrium is basically where it's right here, where you have the same amount and it doesn't change, right? You have all these, you have this much reactants, and then you start getting products, and you get more products. But at this point, it like basically stays the same. The products are turning into reactants at the same speed that they're turning.
I slightly remember, I remember him going over this. So.
I can explain it like easier if you want, cause I get how she explained it.
Okay.
So okay, I'm gonna put this into like layman's terms. Okay, let's say you have 5 markers. Okay,
Yeah.
and then the products are the caps of the markers. Okay, so
I'm gonna ask Miss Alira. You explain that.
okay, and so oh, excuse me. Okay, so basically, these are all the products in here. I'm sorry, all the reactants, right? So you see you have 1, 2, 3, 4 reactants?
Yeah.
As you start breaking off, you get products to the reactants. So you see how this one broke off?
Yeah.
So look, you have 2 products and 3 reactants instead of 4 products. I'm sorry. 3 reactants instead of 4 reactants. And negative 2 products. That's at time equals 10. Okay? Once you get here, you have 4 products and 2 reactants, which is at T20. And T30 is the same thing. So now you know it's at equilibrium because it's not changing. You get it?
I get it now.
You got it.
Right. Okay, so do you know what like the direction of reversible reactions means at all? Okay.
I don't know what that
So,
means.
do you know what a reversible reaction is?
I know like when the equation like you need to reverse it. I don't know like definition.
That's Hess's law, and we don't need that for like 10 minutes. So we'll see. Do you know what this symbol means?
Yeah.
Okay. That's
Real
this
big
is
head.
when you have something like here. This tells you it's a reversible reaction.
Yeah.
And the direction of where it's going is important. So I'm sure you can gather that when you have A and it's decomposing into B and C, that's a forward reaction, right?
Yeah.
Mm-hmm.
And when you have B and C synthesizing into A, which means coming
I'm
together,
back.
Yo.
it's a reverse reaction. Okay? You got that much?
Reverse Chris technique.
No, he doesn't like anime.
Names.
Let me not say slurs.
The rate of okay, better way to I mean 2A. Okay. The rate of the forward reaction is equal to okay, forward. The rate of the forward reaction equals to the concentration of A, right?
Yeah.
That's how fast it is. And the rate of the reverse reaction is Kr. And is equal to the concentration of K, but since we have this number, it's squared. Coefficient, I think it's called. Right? And graphically, you would represent it something like this, where you have the forward reaction and then the reverse reaction. Do you get why? Explain it.
No, you explain it.
Okay. Because we have the forward reaction, right? It's happening first. So it's actually happening. Or it starts at 0, but it's up here. So basically the concentration of A, we have this much. And the less concentration of A, the more concentration of 2A we have. So we start here. And since this is the same graph that we just saw for like earlier, we can say that it's equal to the rate. Because the graph you saw was for the concentration and rate is just the concentration.
Okay, that makes sense.
And applied, basically, oh man, I need that. Okay. What you need to know is that right here, see how the rate of the forward reaction is higher than the rate of the reverse reaction. Okay? This means that there are, you know, when you're solving it, you have to put the products on top, right?
Yeah, and the reactants. Do the reactants go on the bottom? Okay.
Since you have, oh my days. Since you have a greater forward reaction, that means the products are favored. Or something.
Or something.
Or something. It just means that there's more, oh no, I'm wrong. It means that there's more reactants turning into products. Yes, I'm right.
She's right.
Understand?
Yeah.
Okay. And then the reverse is also the same. If, say, it's probably a better way to illustrate it. If the rate of the forward reaction is greater than the rate of the reverse reaction, what does this mean? Can you tell me?
Wait, say it one more time.
If the rate of the forward reaction, i.e. the concentration of the reactants, is greater than the rate of the reverse reaction, i.e. the concentration of the products, what does that say about the net?
It's not
rate?
equilibriums.
Yes, that's also, yeah, that's a very good observation. I like that connection.
Thanks, he's
Do you want my help or not?
Yeah, no, I'm saying.
Okay. It also means that we have more reactants. So this is a lot more than product. Right?
Mm-hmm.
Because the bottom number, when it's bigger,
It means it's more.
it means it's more.
Ooh, that's tough. That's tough.
Something. Wait a minute.
Fuck you, me. She's on to something. She's teaching us this. She know what she on to.
And what happens when it's equal? When the rate of the forward reaction is the same as the rate of the reverse reaction.
It's at equilibrium, and there's the same amount of products as reactants.
No,
No?
but it's
Ooh,
at equilibrium.
I was close.
The same.
I was close.
The relative amount is not what we're learning right now. Give me like 5 minutes.
Okay.
Okay, what happens when the rate of the forward reaction is less than the rate of the reverse reaction? What does that mean?
Good question. Nate, what do you think?
Nate, what do you...
Okay, let's come back. So we have the rate of the forward reaction, which is the products, or which is the reactants, which comes on the bottom, and it's less, and reactants are less than the top number, the products, which is the forward reaction. So this is more. If we have more products and less reactants, what does it say about the equation? You know what it says? It says that we have more products and less reactants, right?
Yes.
Mhm.
Okay,
Yes.
you understand that?
Yes.
Yeah.
Okay, say it back to me.
I thought you were looking for like a specific term or something.
Yeah, I probably was, but I forgot it. But, like, what you want to say here is that the reactants are favored.
Okay.
No, they're not.
No. It's favored. No. Favored.
Shut up, bro.
Ah!
No. It's
Okay.
because you have like in that one you have less. Whichever has less is whichever has more is the one it's shifting to, right?
Huh?
No. If there's less, it's shifting this way. Because you have more reactants, so it's going.
So it's in favor of the.
Faber.
You know what? I don't even know.
I already know. I low key
you
already
guys
understand it more.
You guys were understanding.
I already understand it more than Mr. V taught it.
Yeah, low key, because like Mr. I don't know.
He's boring.
He is.
Yeah.
She doesn't even teach. She just gives you
Worksheets.
But does it work though?
Yes, it's like
Well,
self-guided notes and you actually understand it. I know because I was in the period for one.
He was in one period.
One
He got kicked out of AP Spanish for the day.
for one day. And
How
then
did you
I-
kick that? How did
Cause when he took the pretest, you know how like pretest quote don't matter.
Yeah.
He didn't.
I took that to heart.
He took it to her and wrote like abracadabra or something.
Yeah, I put ABCD, and then she thought I was actually trying for real. So she kicked me out saying I wasn't ready. And then I talked to her and she's like, oh, okay, take the pretest and show me. And then I did. I did it again and I passed. And she was like, okay, you can come back.
You can come back.
She's
But
like,
she
you
put
can
your
come
ass back in Spanish 3.
Okay, do you guys know
No,
what the
I just
equilibrium
finished.
constant is?
Equilibrium constant.
It's basically another word for
She put me in Spanish 1.
the K that we were talking about, right?
Uh huh.
This whole time, this whole class. Like, so KP, or KC and KP. This is your equilibrium constant. That's what it's called. Okay?
KCKP.
To find the
Ooh,
equilibrium constant.
we're getting somewhere. I know what I kind of know.
I
what this is.
know KC and KP, the formulas and
You
everything.
know the
I know the formula.
Okay,
It's easy.
I can skip over it?
Yes.
No.
Okay,
Okay.
we'll go over.
So to find KC and KP, it's like the same formula, but it's written different because they mean different things. To find the equilibrium constant using concentrations, you know what concentrations are? Of how much of something is in like whatever
Something.
you're doing. Yeah, basically.
Okay.
Can I write the formulas?
Yeah.
Oh, lil' bro getting smart with it. Lil' bro getting smart with it.
Excuse me.
Lil' bloody getting smart.
KC is just
KC is the brackets.
KC is the brackets, and then KP.
oh, yeah, it's a parentheses.
KP is the
I
parenthesis.
started it here.
Isn't KP
Start
the?
with like
Okay.
the reaction.
It's got ego like 3 different
Okay.
times.
Start with the reaction. So we have. Oh my days. Stupid ass. Start with the reaction.
Oh, okay, then why was the A there?
A plus B. Hello.
Yeah, then, oh, okay. I'm like, what are you
The
talking
lowercase a is the coefficient.
Okay.
Stop it.
about? Yeah, why did I see it? Anyways,
Flabs. I'll mark that for you.
right? That's, okay. Is that a yes or no?
No, you can write the expression, and I will write the.
Thingy. I'm a bobber.
So if you have this much of element A plus this much
Oh.
of I'm sorry
No.
Oh.
of
No.
B, and then reverse reaction
You look so sad.
C plus D. That's how you would find the. When you're doing the pressure reaction, you have to have the.
I gotta keep turning the gain up.
Have it like right under it. So the partial pressure of that.
That was loud.
You have the partial pressure of C raised to whatever coefficient of the loop.
Can you mark it like that?
And if you have D, and so on. Right?
Yeah. So
Okay,
you
so do you know how to apply it?
can't you like okay.
Okay, I'll give you an equation. And I'll give you, and you can use a calculator.
Ooh. Talk about some calculator. Calc is short for calculator, by the way. I don't know if
Yeah,
you
for
know that.
people who use the chat,
You know how to apply this,
we're just
right?
using slang.
And
Calc is short for calculator, guys.
do you know what to do when there's pure solids or pure liquids? Because
Huh?
really these are all gases, right?
I don't know how to do with gases.
Okay.
I don't know what to do.
If you have a pure gas or a pure liquid, you don't use it. You ignore it. So let's say
21.
like 4 different things I can do for you guys. So let's say that this is a gas, and this is a gas, and this is gas, but this is a salt.
You just ignore it?
Yeah, it basically would be like.
You
the
ignore
C
it and don't put it in the equation?
Oh, yeah, I
over-
remember.
yeah.
Yeah.
Do you just not put it in the equation? That's
Because
like
it's.
I low-key don't know
Because
what
the
gas.
concentration of a solid and liquid are going to stay the same throughout a reaction, right?
Wait, I have a question.
I have an answer.
So, look, you see
Uh-huh.
in the...
Where are you going?
KP? The
Why
pH
is he
the
standing out there
pressures
like
of
that?
the-
They're going to give that to you.
Okay. And then this is the...
Coefficient.
And this is the... Just the formula?
Yeah, they're going to give you, so let's say that this is NO, right?
Yeah.
They're going to say the partial pressure of NO. And instead of writing like the P, you just write.
The pressure and then NO, and then that'd be the coefficient.
Yeah.
And then for this one, the middle one is the actual like element,
Mhm.
and then that's the coefficient.
Yeah.
Okay.
It's always going to be raised to the coefficient. I'm going to give you an equation, and I want you to give me the.
Wait, I'm so tall.
He's open.
Now watch me fall.
Low-key,
I want the KC
I think
expression.
a mosquito bit my left cheek.
How do you even get that, Kyle?
How does this even
Cause
happen?
I sleep my.
And these are all gases.
Okay, bet that. Right for KC,
After
so we
that-
got.
This is like the Khan Academy videos, by the way. So you should be able to do the tests.
Do you have an example one for Casey? Like so.
She just gave me one.
Yeah, I'll write it up here.
Okay, so
Oh, my dear.
Casey's the
This
brackets,
is- yeah.
right?
Casey's easy to make it. And 2.
No, 2NH is what you wrote.
Hello. That's the that's the products.
Wait,
I maybe can.
So hopefully you can understand this much and I don't help you during class. Another thing, when it's all gases, it's called homogeneous or homogeneous reaction.
Homo.
And when there's and when there's like a solid or a liquid, it's called a heterogeneous.
heterozygous.
Yeah.
Alright, I think I didn't. I don't even know though.
Tyler was heterozygous, maybe.
So C, since
Interesting.
the H2 is a has the coefficient of 3 in front of it, instead of writing 3,
Is that H?
yeah.
That was an N.
Instead of writing, you wrote H.
Oh.
Instead of writing the 3 in the brackets, it would be raised to the 3rd power. And
Okay.
the same problem you have with the 2 and H. It would be raised to the 2nd power instead of with the 2 instead of. What's up?
Okay.
Yeah. No.
No. Yeah, no.
Yours is wrong.
His is-
The products goes on top.
Oh shit.
You have to say it. Sorry.
Okay. And that's it, right?
Yeah.
This is way easier than Unit 6, I'm not gonna lie.
Yeah, it's just easier to get like all the stuff.
So why don't you
Can you
study
read my
Unit
handwriting?
6?
No, because Unit 6 is really hard, and it's like been a while. I'm saying this unit is way easier than last unit.
Yeah, don't you have a Unit 6 test?
No, this is Unit 7.
Yeah.
Unit 6 was...
Wait, so like this then?
This will be on the outside of the bracket.
Oh shit.
Can you read my handwriting?
Really?
Can you read it out to me?
Oh.
Can you not read your own handwriting?
Yeah, that's what I thought. No, but I'm freaking erasing something, stupid ass.
Whoa, whoa, whoa,
To the
whoa.
top of the page.
You guys like
I
to
finished
say your
erasing.
podcast.
I finished erasing.
Oh, okay, okay. Wait, actually, I want to see if I can read your hand.
And where can we rewatch
The-
this podcast?
On
Don't
YouTube.
need to.
Okay.
Do you want to? We're super funny.
Yeah, never mind.
Yeah, that's what I thought.
Yeah, never mind.
Okay. So that's how you find the K
I wonder
of
what
something.
this is.
That's what I taught you. And the K of something is when you find something at equilibrium. Okay?
Yes.
You understand that?
Yes.
Internalize that. K means
Equilibrium.
equilibrium.
Two topic.
When you're looking for the C of something,
Shit, you wouldn't even be able to find it. I have to send you the link myself.
yeah.
There's
when-
two C's.
yeah. Sorry. When you're looking for the Q of something, that's
I'll
at
probably send
any
you
point
later.
in time. Do you understand that when you're looking for the K of anything, it's at equilibrium?
Yes.
Okay. And when you're looking for the Q of something, it's what?
Not equilibrium.
There we go. It's at any point in time. So it's relative. And it's written the same way, basically. Just with a Q. Can you not? So to find
Okay.
okay.
That is not.
So to
It's,
find
don't let
the
that guy in.
K of H of this, it's the same as finding the Q except oh, wait, I
Except?
just explained it.
No, you didn't.
Okay.
The Q is almost the same.
It's the same. It's written the same way.
But just with the Q
But
instead
the
of a K.
difference is like K is at equilibrium and Q is not at equilibrium. Or it can be anytime. It can be at equilibrium. So it's we don't
So-
know.
Q can or can't be at equilibrium.
Yeah, it can be, it's whatever. So if equilibrium is less than the Q that we find, what do you think this means when like you're reading it?
That is less than equal.
That is not equilibrium.
Yeah,
It's
it's
not.
not at equilibrium.
Or will not. Bless you. Thank
Bless
you.
you.
You're welcome.
And it's like this means just like just before equilibrium.
Just before
The
equilibrium.
formula for QC is the same, right?
You literally just replace the K with the Q. What about when K is greater than
It's above equilibrium.
what about when it's equal?
And then it's equilibrium.
There we go.
That's tough.
You guys like
I
and
learned.
you know how to apply this, right?
Yeah, I just didn't.
Okay.
On
Okay,
Buddha.
so I'm gonna give you
Practice problem.
And you guys know how to.
Just wait till we get to rice.
I
How
hate
did you
rice
know?
tables.
Rice tables are actually really easy and really easy.
I was about to say I thought she was about to say fun. I was about to knock her out.
I don't like them. In Khan Academy, they use ice tables and like, it's
Ice?
insane.
Ice?
Ice.
Ice?
Yeah, because they don't really.
Instead of rice.
I know
Yeah,
y'all
because they
scared
just
of
they
ice.
have the.
Who is
Oh,
y'all?
so they don't use. Okay.
Why are you scared of ice? Oh, you are definitely
Yes,
scared of ice.
well, no, I'm Puerto Rican, so it's like
Let's still deport your ass.
back to territory.
Back to Puerto Rico.
Back to Puerto Rico.
Okay, you guys know how to apply it, right?
Yeah.
Like with numbers.
See, Typhool will probably be scared of ice.
Oh, for
I was
sure.
born here, but I
You're
am
lying.
Peruvian.
Exactly.
I'm sending back to Peru.
They will send you back to Peru.
I'm not. Peru
Yeah, have
is
you
the
ever had
India of
guinea
South
pig?
America. I ain't
What?
okay. Peru is the Indian of South America.
She don't look Indian to me.
It's like the culturally, it's like y'all are dirty.
More like
Y'all are
more like
dirty.
Philippines, bro.
Y'all are culturally dirty.
Okay, do you guys want my help or not?
Yes.
Have you ever had a guinea pig before?
It's really good.
Oh,
It's
no.
really good.
Oh, no. Oh, no. Actually, you've had guinea pig?
Yeah.
What does it taste like?
Chicken.
Yeah, a little bit.
Rabbit tastes like chicken, and it's good.
Why y'all eating these exotic ass animals? Most
Exotic. You're finding guinea pig at freaking PetSmart, yo.
you eat the guinea pig from PetSmart?
No, I ate it.
From PetSmart.
she eat the guinea pig
No,
from
I ate it in
PetSmart.
Peru at like some river place.
No,
Nah, she got it at PetSmart, the Peruvian PetSmart.
That's
Peruvian
them
pet-
Asian.
Yo, that's what I'm saying. That's what I'm saying. I'm not gonna lie, y'all have the best food, but that's it.
Nah. You know who got the best
You'd be
food?
surprised.
Black people got the best food.
Hell
We got
yeah.
fried chicken.
Okay,
Y'all
you
got
guys,
AMC.
They didn't look
how do you
you.
find the magnitude using the equilibrium?
What the fuck is it
Yeah,
magnitude?
it's their fucking thoughts. Shut
Hey,
up.
fuck My bad.
Okay,
I'm
so
sorry.
In this first example,
What is that?
I'm
It
sorry.
did.
it's basically
Continue. Just continue explaining.
That's what she's doing, fuck ass.
No, I thought she was gonna write a problem.
I'm gonna explain it, little bro. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. You understand that?
You can count.
Okay. Look. So let's say the stars are the reactants.
Okay.
Where do they go? Do they go on the bottom or
They
the
go on
top?
the bottom.
Top.
Wait, is this K
Bottom
or
or top of what?
The top.
Of the
Wow.
AC equation.
Wait, no, is it not
Oh,
the
wait.
bottom?
No, they go
Top.
the top.
Okay.
No, the bottom.
Reactants?
Wait,
Reactants?
are
Reactants go on the bottom.
Reactants
Oh no,
are the
reactors are on this side, so they go on the top.
No.
No,
No, they
wait.
go on the bottom.
No, reactants are on this side. Reactants react to make a product.
Wait, no. Products. So products on the right, reactants on the left,
Lost.
Yes.
Yes.
and then which way?
Okay, so look, we have 5 stars, right? So they go on the bottom, and we have 5 dots, so they go on the top. What's 5 divided by 5,
One.
guys?
1.
Wow.
Shut your ass up.
Look, when KC is like close to 1, hello, what was that?
But here's some ASMR. Mid
Okay,
podcast.
when the equilibrium is close to 1, what do you think it means in regards to the magnitude? Magnitude means how much of either reactant there is.
That means
Okay, so that means they're
That's not a lot of
equal and
magnet.
near equal.
Yes! Yes, you got it, you understood it on my days! Okay, what about?
you sound like you've been explaining this to them for the past 3 hours.
I was really nervous that you wouldn't get it.
Oh.
Okay, so look, now we have 1 product, 2, 4, 5. So how many stars do we have?
Yeah.
One.
One star.
No. 6.
No.
There's 5.
Where did you get 6 from,
I
dog?
Just
swear
5
I saw
stars.
6.
Fuck you.
How many dots do we have?
1. So it'd be 1 over 5.
Uh-huh. So that means it's
Star over dot over star.
What's the decimal?
okay, that's not what I'm asking for. Is it greater than, equal to, or less than 1?
It is less than 1.
What do you think that means?
That is not at
Equals the
every. No, it's not.
This is equilibrium, okay?
Oh.
But what does it mean, like, when we're saying the magnitude of either one of these? Magnitude being how much one or the other. If you want me to break it down, we have,
Is it about the ratio?
yes, the ratio.
And 1 means they're equal, like it's 1-to-1 ratio, right?
Yes.
Okay, so
So.
if
Oh
it's,
wait.
if it's less than 1,
Uh-huh. Another way to say it is that there are, this is products, there's P and there's R. You have more
reactants,
then
products.
because
Just less than one,
Is
or it's
less
greater
than
than one. Sorry.
it's less than one.
So if it's greater than 1, you have more products.
Yes. You know why? Because when you divide something, the top one. Right?
Yeah.
You understand division.
Yeah,
Uh-huh.
I
Okay.
see the vision. I see the vision.
Okay, that's not, I said division.
I know, but I still see the vision.
Okay.
Am I bleeding?
Probably.
Likely.
A little bit,
A
but
little bit. Give me like.
That my mom.
I'll be right back.
Okay, so just a little reveal.
Uh-huh.
So if it's less than 1, the reactants are bigger,
Yes.
and if it's greater than 1, that means the products are bigger. They have more.
Very good. Okay. So properties of equilibrium constant. This is using it
Take it.
applied to Hess's law. You know Hess's law?
I'm sure I do. I just don't not by heart.
It's basically when you have reactant 1, we'll call it reactant A, and a reactant B. And then you want to find how to get reaction C when you add these together. Okay? Let's say that you have to reverse this reaction, and you have to double this reaction. To find, and you want to find the KC here from this reaction. And as long as you have this, and you have this, and you have K, they'll give you KB and they'll give you KA, ideally, right? Because that's all it works. To find the revert, and to find this, you have to multiply these two, okay?
Ka times Kb equals Kc.
Yes, but when you have to multiply the B reaction by 2, what do you do to the KB?
Divide it. Have we multiply it by 2.
So since we're multiplying it, we're taking it to the next step up, so we're squaring it.
Oh, okay.
And since you have the reverse reaction, what do you think you do?
I don't know.
You use the reciprocal, right? So since
1 over Kc.
for KA.
Okay.
Another way to write this is just KB squared divided by KA. Do you understand why?
Because you're multiplying.
Yeah.
So.
I think you can do a couple quizzes. Because that's all.
Give me a practice problem on that.
This can give you a practice problem.
What I miss?
Oh, this is the first
That,
exercise.
whatever's on the board.
Okay. Do that, and then if you need help, I don't have a pen for you.
Amazing. I had a
Give
pencil.
that for him. Okay, so basically, do you know Hess's law at home?
No.
Okay. When you have, I might actually have to write out. Okay. So it's basically when you have 2 reactions and you add them together to make a third reaction. You remember that?
Yeah.
Okay. So you can use that to find the equilibrium constant of the third equation, right? Because they're gonna give you the equilibrium constant for the second and the first reaction. Right, so this is reaction A, and this is reaction B, and this is the reaction C, like, that you want to find. Let's say you have to multiply reaction B by 2. You
Okay.
understand why?
Yeah.
And you have to reverse this reaction. To get KC, basically you have to multiply these 2, but before you do that, you have to perform these actions onto these, right? So to get the reverse, you have to find the reciprocal, which is
Just
1 over.
yeah.
And to get, if you have to multiply it by 2 or any number, you take it up to that power, right? You're on Instagram.
No,
You're
sorry.
on Instagram.
No,
I'm
that's
trying
right.
my best here, bro.
No, I was waiting for you to be done explaining because I need help on this problem.
Okay, and you understand that you just multiply these two.
Yeah. Divide that
Okay.
one and then multiply the second one.
Yeah. Okay, there you go. Open kind of.
What is this asking for?
Okay. We have 5 minutes. Try to do.
AB classroom or common?
No.
I did Khan Academy.
Which one do you recommend?
I don't know.
Okay.
I'm gonna do both tonight, so we'll see.
Tonight.
The reaction. This is just telling you like the conditions. So you have to read it, but it doesn't matter. The partial pressure. So since it's partial pressure, you know it's Kp, right? Of this at equilibrium is 3. And you have
Wait.
uh-huh.
Okay, tell me if this is right? What is this? You ignore this because this is solvent, right?
Mm-hmm.
Okay, so you have CO2. You're trying to find this, and we know that
Hey, what is it called? Equilibrium?
Kp is 2.
Mm-hmm.
So you got to do some algebraic stuff to find the answer, right?
Yeah.
So
Changes in equal. Wait, which one? There's a bunch here.
2CO.
Oh, which one?
Equilibrium.
No, like it's like a bunch.
Changes.
The first one here.
Would it be okay? So you see how it says CO is 3. So that means 2CO would be 6.
Yeah.
I guess not.
I don't like this question. What the hell?
Wait, hold on. Assuming all other factors remain constant and if the income of book buyers increases, what will happen? This is more like a business question than equilibrium.
Would it not be 3, 2, right?
3 over 2. It could be. That's so weird. If partial pressure, CO, I think this is a rice table.
In the back of my mind, I was like, what if this is a rice table?
Initial.
You guys got 3 minutes.
Because we don't have an
That's like
Okay, it's not a rice table. So we don't have the initial. Equilibrium. This is 3.
Oh,
Why is this one so weird? Hello?
that's literally what I did.
You squared it.
Oh, I didn't square. I times
The what?
So it's 3. Why is it not 3? What the fuck?
It is someone.
Go to sleep. It's sleepy time.
Marking.
Why does it square?
You know, you ever seen YNA before?
Y and A.
Hold on.
It would be 3 times 3 is 9.
Because
Oh.
it equals 2, and you have to fit.
For the treasure?
Okay.
That is my charger, dog.
Do not gaslight him.
No, it isn't.
That's my charger.
Do not gaslight him. Do not
That
gaslight
is
him.
my charger, dog.
No, it isn't.
That is my charger,
Do
dog.
not gaslight him, bro.
That is my charger,
It would
dog.
be 9 over.
The time is
It's
not
1.5.
waking.
It's not over 2.
Dog.
Yeah.
This is
And
my charger.
Because you
Wait,
have
I
to
don't
set
got
it
a charger. I asked
You
you
have to set it
first.
equal. Okay.
Oh, wait,
That is your charger. That is his charger.
Are you stupid?
We squared, and you don't know x right now. You have to set it equal to 2.
No, that's
and
Enrique
this
for the
is just
treasure.
Hold on.
Oh, okay. So it'd be
Not
3
over 2.
3 times 3 is 9. So it'd be 9 over x equals 2. So you multiply
X.
to get
Alright.
this side and then divide over here.
Say goodbye.
3 over 2. And
Bye.
3 over 2.
Bye,
you get
guys.
it as a decimal.